Okay, so now I'd like to talk about Mercury's atmosphere, or I should really say lack of atmosphere. So the Earth has an atmosphere. We know about the Earth's atmosphere. We know that the Earth has an average pressure of 1 bar, and Mercury, it doesn't really have one. It does have gases that if they were allowed to, they could accumulate to make an atmosphere, but they're just not allowed to. We're going to talk about why that is. So instead of an atmosphere, Mercury, it possesses a thin exosphere, which is made up of atoms of sodium, helium, hydrogen, and potassium. And those gases come from the rocks on the surface of Mercury, and then also the sun as well. So those are the gases that could make up an atmosphere if they were allowed to, but unfortunately, with Mercury being so close to the sun, it's just too hot, and Mercury's mass is just too low to accumulate an atmosphere. So it is a very, very low mass planet. The mass of Mercury compared to the Earth, it is 1/20th the mass. 1/20th. That is extremely tiny amount of mass. So since it is such a low mass planet, that means that it is very easy for those gases that are in the exosphere of Mercury to escape out into space. So sodium and oxygen and potassium, those come from the actual rocks on the surface of Mercury. It is so hot during the daytime on Mercury that those rocks will heat up and give off those gases. And then the sun gives off hydrogen and helium, and that just comes down and it just kind of blasts all over the surface of Mercury. So because of the high temperature and the low mass of Mercury, it's very easy for all these gases to escape. But again, the gases that it could have if it were allowed to accumulate would be hydrogen, helium, sodium, potassium, and oxygen. So there's really almost no atmosphere. It's just an exosphere is all there is. So sodium, oxygen, potassium from the outgassing of those rocks, and then hydrogen and helium from the sun. The reason Mercury looks the way it does, we said in the last video that it looks a lot like the moon, except there's no Maria. It's because there's no weather. There's no atmosphere, there's no rain, there's no wind except the solar wind from the sun. So there's very, very little erosion, which makes it have a very, very old surface, which is why there's so many craters. And we also said that, there's craters inside of craters inside of craters. And basically that's the main surface feature you need to know about Mercury is that there are lots of craters. There's one large region of craters in particular. It's called the Caloris Basin. It's over 960 miles across, and I'll show you that in just a little bit. So when you're observing Mercury, Mercury is, we said before, it's 0.4 AUs away from the sun, which means that it's close to the sun. And Mercury and Venus, they're both, you can either see them as the sun is setting or as the sun is rising. So when you go outside, right as the sun is setting, and if you see what looks like a star in the sky and nothing else, that's not actually a star, that would be a planet. And it's either going to be Mercury or Venus. So Mercury is going to be no more than 28 degrees away from the sun at sunset, sorry. And then Venus is no more than 47 degrees away from the sun. So if you see something in the sky when the sun rises or sets, that's either going to be Mercury or Venus, and not a star, because if there were other stars in the sky, you'd see them. And if you only see those one dot or two dots, those are planets and not stars. So Mercury's interior, we said Mercury has an interior that it would be very similar to the Earth's. It has a very similar density of 5.42 grams per centimeter cubed. And the reason it is so high density-wise compared to, similar to the Earth, is because it has this very, very large core of iron. So it's a mixture of liquid and solid iron. And then you can see the mantle, though, is not as big. So the mantle is a little smaller, and then there's the crust as well. So the reason astronomers think the mantle is smaller is because it was too hot, since it's so close to the sun. It's too hot for lighter elements to accumulate on the surface. And then also, since it was hit so many times, all those craters and all the ejecta from those impacts blew off of Mercury, and would have the gravitational pull of the sun would have pulled that material into the sun. So that's where we believe the mantle went. It was blown off. So very large core, smaller mantle, and then you have the crust here. So here's a comparison of Mercury and Earth, their sizes. So we said Mercury is 2/5 the size, the radius or the diameter compared to the Earth, but you can see their cores. Mercury has a very, very large core compared to Earth. Earth has a larger core, of course, but most of the core, most of the Earth is mantle, whereas most of Mercury is core. And what that means is if Mercury was actually further away from the sun, it probably would have been a planet similar to the Earth. It just did not have a chance to do that because of its proximity to the sun. So why a thin mantle? We just kind of went over this. We said it's too hot for lighter elements to collect to form the mantle. And then we also said the collisions with all those meteoroids, asteroids, comets, things like that, whenever they hit, they blew off lots of material as ejecta, and that ejecta would have been put into the sun. So the mantle was actually knocked away from those planetesimals hitting the Mercury. And then the solar wind as well would have blown it away. This is what a transit of Mercury looks like. I told you about this last semester. I asked you to go out and look at it if you could. But the last one was last one for a while was last year in November. This little dot here represents Mercury going across the sun. So this little dot here. So this would have been several images of Mercury taken, and then just each photo would have been put on top of each other to show you this it's called a transit of Mercury. So anytime a planet moves across the surface of the sun, that's called a transit. The only transits we can see are on the Earth here are of Mercury and Venus. We won't be able to see one of Venus. The next one's going to be quite a while before the next one. And then Mercury, there's going to be another one. I have it coming up on another slide. I want to say it's going to be 2032. But on average, you have a transit of Mercury every 7 years on average. And there have been a couple that have happened over the last few years, but it's going to be a while before the next one. So we'll go over that in just a little bit. So this little dot right here, that's what Mercury looks like when it crosses the surface of the sun. Right there, that's Mercury. This would be a sunspot. So we've talked about sunspots. We'll talk about sunspots when we get to the sun. So 2032, November 13th, 2032 will be the next transit of Mercury. And the last one was on November 11th of 2019. So if you didn't see it then, you're going to have to wait a little while before you can see a transit happen again. But on average, again, they last. They happen once every 7 years on average. So since Mercury is closer to us, closer to the sun than we are, we can see Mercury go through phases just like the moon and just like Venus as well. We've already said as well in my last video, we said Mercury, it's known as a morning or evening star because you can see it either at sunrise or sunset. Since it's so close to the sun, it will not stay out long in the sky after the sun sets, and after the sun rises, it will not stay out either. Because as the sun gets bigger in the sky, it gets brighter, it's harder to see Mercury and Venus. So that's why they're called morning and evening stars, because you can only see them at sunrise or sunset. So surface features. We've talked a little bit about craters. So there's lots of craters. The main crater I want you to know is called the Caloris Basin. I'll show you images of that coming up. And then I want you to know what scarps are as well. So craters and scarps are the main features. There's mountains as well. We talked about crater rays and riles, what those are. Sorry, riles were on the moon. We talked about crater rays, what those are. When we talked about the moon with the ejecta spewing out of those craters and forming those rays. Same thing happens on Mercury, but we have not mentioned a scarp before. So a scarp is just a cliff on Mercury, and the way they form from, it's like tides on the Earth. So the sun's gravity will actually pull Mercury's surface, and when it pulls on the surface, and because of the temperature and that gravity, it can actually rip the surface of Mercury, and it causes cliffs, and those cliffs are called scarps. So these are just images I took from the NASA website. Just shows you how heavily cratered Mercury is. And we've gotten these images. We've actually the U.S. has been to Mercury twice. There have been 2 spacecraft that have gone, the Mariner 10 and then the Messenger probe as well. So here you can just see a lot of craters. And these were taken from the Pioneer 10 when it went. That was back in the 70s. When we go to Mercury, the reason we haven't been very many times is because it's hard to get a spacecraft to actually orbit around Mercury because it's so close to the sun. So we didn't really have the technology to get a spacecraft to orbit around until recently. So there's only been 2 that we've sent. There's actually one that's being sent now. It's a combination of the European Space Agency with the Japanese Space Agency. They have a probe that they've sent to Mercury that they're going to try to get it to orbit around, and that'll be the next probe that we have information with Mercury about. But we only have 2 so far, so I'll show you pictures of them coming up. But this is just showing you a bunch of craters, because there are a bunch of craters. So the Caloris Basin is the main one. It is over 960 miles across. And the reason they call it a basin, basically a basin is what geologists call craters larger than, I think it's 186 miles in diameter. So if you have a crater larger than that, it's called a basin. And there's lots of craters that actually happen inside of this one large crater. But that's a very large surface feature of Mercury called the Caloris Impact Basin. And then here you can see just a scarp, which again, it's just a cliff or crack in the surface of Mercury causing cliffs. So largest crater on Mercury, Caloris Impact Basin. This is one of the more recent pictures from the MESSENGER probe. When it went, it gave us photos like this, a little more high definition, high resolution. So this going across would be part of the Caloris Impact Basin, over 960 miles across. And then this just shows you the inside of one of the craters. Here you can see we talked about the central uplifts when we talked about the moon. So it has a very large central uplift. And you can see just how large these craters are on Mercury. There's another scarp here. Shows you how long these scarps can be. So this is about 120 miles across. So these cliffs can be pretty big. And this is kind of interesting as well. So the hit that happened, the planetesimal that hit Mercury to create the Caloris Impact Basin. So if this is Mercury, here's where the Caloris Impact Basin happened. When that impact happened, the seismic waves that were sent through the planet actually messed up the terrain on the other side of Mercury. So the complete other side of Mercury has weird terrain. It has all these grooves that just look really, really weird. And that's because of the impact from the Caloris Impact Basin forming. It was such a large planetesimal that hit. So kind of neat that it can do such damage all the way on the other side of Mercury as well. And there's just a couple of craters here in the Caloris Impact Basin. Here you can see the ejecta blanket of these craters. And then here's those crater rays that we talked about a lot about when we talked about the moon. So long streaks of pulverized rock or ejecta, that's what a crater ray is there. So geological features on Mercury, we're getting close to being done now. There really aren't any geological features on Mercury. There's no active volcanoes. There's no plate tectonics. There is evidence of old lava flows, but that was not from volcanoes. So there are areas where there has lava that's flowed, but it's probably coming up from the surface, not as a volcano like we have on the Earth. And that is not, that would be old lava. It is not still hot. It would be cool. Mercury is the same age of all the other planets in the solar system. They all formed, around 4.5 billion years ago or so. So that's how old Mercury is as well. Now, magnetic field. So we need to know what causes magnetic fields. That will definitely be on your test. So we know that there are 2 conditions needed to form a magnetic field. You need a metal core, liquid metal core, and you need fast rotation. So Mercury has a very slow rotation. It takes 59 days for it to rotate once. That's a sidereal day again. But it does have a very, very large metal core. So it does have a little magnetic field. It's actually about 1% the strength of the Earth's. So it does have a very, very, very small, very weak magnetic field, but it is not much of one. And that's because it does not meet those 2 criteria to have a strong magnetic field. It does have a liquid metal core, but it does not have fast rotation. It's very slow rotation. So we need to know the names of the 2 spacecraft that NASA has sent to study Mercury. The first one was the Mariner 10. It did a flyby. It did 2 flybys actually. So 1974 and then also 1975. It was launched in 1973, and this is what it looked like. So not much to it. And when it went by, it actually took pictures of the surface but we did not actually get a complete scan of the planet because since it rotates so slowly, we didn't actually have pictures of the entire surface of Mercury until we went back with the MESSENGER probe. So the MESSENGER probe, this is what the MESSENGER probe looked like. It was launched in 2004. It was able to insert into orbit in 2011, and it just orbited around Mercury, studying it until April 30th, 2015. On that date, they actually crashed the MESSENGER into the surface of Mercury to get it out of the way of any other any other probe that was going to go study Mercury. So the next one, again, it's been launched and it'll be there in orbital insertion in the next couple of years. I don't remember the exact date. I'll have to look that up. But in the next few years, they want to get the Japanese and the European space agencies, they want to get their probe to insert into orbit around Mercury. But we've only had the two, MESSENGER and the Mariner 10. And this just shows you an image of Mercury. If you go to NASA's website, they have a lot of high definition images. Again, it looks a lot like the moon, but there is no Maria. So there's not much color to it. It's just a very, very subtle gray color and white. And that's about it for Mercury. Let's see. Yep. So that is it for Mercury.